Let's start now. So number 4, you're given this diagram right here. So this diagram here shows part of the curve y is equal to x plus 1 times x minus 2. So find the area of the shaded region. So as you guys can see, the shaded region is below the x-axis. So that means your function here should be multiplied with -1. That's it. So what I did here, all your workings are correct. Okay, so mine is a little bit longer because I want you guys to see like each step. So anyway, let's begin here. So we were given this. So what I did here, basically I simplify that. So it becomes x squared minus x minus 2. Since the area is below the x-axis, so basically this one is multiplied by -1. So therefore, my equation now is negative x squared plus x plus 2. So this is now the equation for the shaded region. So basically, to find this, we are bounded by the limits from 2 to -1. Okay. Alright, so I think I got a mistake here. Alright, so this is to -1. Okay. So the area of the shaded region is equal to the antiderivative of negative x squared plus x plus 2 from 2 to -1. Okay, so let's have the answer for this. So we got negative x cubed over 3 plus x squared over 2 and then plus 2x. So let's find the answer for this. So this is your upper limit. So we plug in 2, 2, and 2, and then minus your lower limit. So we plug in -1, -1, and -1 here. So evaluating this, guys, so we will have 4.5 or 9 over 2 square units. Okay, so that's the answer for number 4. Okay, now let's go to number 7. Okay, now for number 7, the diagram shows part of the curve y is equal to e raised to -x. Okay, so this is an exponential function. Okay, so first question is find in terms of a the area of the shaded region, and then b, given that the area of the shaded region is zero point 0.5 units squared, find the value of a. So basically for letter a, we need to find the antiderivative of e raised to -x from a to 0. Okay, so this one. So the antiderivative of this is basically negative e raised to -x from an a to 0. So answering this, we'll have 1 minus e raised to -a square units. Okay, so this is the answer for letter A. Now for letter B, it says there that this is equal to 0.5 square units. Okay, sorry, my units here is wrong. Okay. Okay, so this one is the equation. So this one is letter B. So we have 1 minus e raised to -a equals 0.5. And then solving for a, so what I did here is to transpose zero point 0.5 here, and then negative e to the right side, so just to make it positive. Okay, so answering this, you'll get 0 0.5. And then again, how do you get rid of e? So you plug in or you multiply them by ln. So answering this, so negative a will be multiplied here in form, so negative a. So you have here negative a because uh, ln of e is equal to 1. So it's basically right here. But yeah. So evaluating this, ln of 0.5, you'll get negative 0.69. So solving for a, the the value of a is 0.69. Question before we go to the y-axis. So this one, as you can see, this is a combination of a positive function and a negative function, because as you can see, region B is below the x-axis. So let me read the question. So the diagram shows part of the curve y is equal to -1 plus 9 over x squared. Okay. So we need to find the area of the two shaded regions. So area of region A and region B. So basically, getting the area of region A is, of course, easier compared to getting the area of region B. So let's have area of region A. So we got here the equation. So -1 plus 9 over x squared from 3 to 2. Here, bounded by this limits. Okay. So simplifying this or rewriting this, I should get -1 plus 9 x raised to -2. So I should get the antiderivative of this. So -1 becomes -x, and then 9 put aside here. So this is -2 plus 1. So therefore you have -1 over -1. So simplifying this, I'll get -x minus 9 over x. Okay, this one goes back to the denominator. So let's evaluate this now. So upper limit, so this is 3. And then minus your lower limit, which is 2, and then 2 here. So that gives you 1/2 square units. Okay, so that's the area of region A. Now for region B, okay, we know that the shaded area is below the x-axis. So therefore, this now is multiplied by a -1. Okay. Okay, so we multiply this by -1. So therefore, this is now our new equation. So 1 minus 9 over x squared. So again, we need to write this. So it becomes this. So it becomes 1 minus 9x raised to -2. Getting the antiderivative of this, we'll have x plus 9 over x. Okay. Okay, 9 over x because again, -9. And then we have x raised to -1 over -1. So this and this will give you positive 9. And the -1 here will go back to its denominator or to the denominator. So let's evaluate this. So we get our upper limit minus our lower limit. So your answer is 4 over 5 square units. So basically okay, the answers are again 1/2 and 4 over 5. Okay. So that's example number 6. Okay, now this is our next topic. So what if the area now is bounded on the y-axis? So it's connected now to the y-axis. Okay. So basically, it's almost just the same. Okay, we just, of course, our function now is in terms of y instead of x. Okay. So the area bounded by the curve x is equal to h of y. The y-axis and the lines y is equal to a and y is equal to b, so it's bounded by this. So being b is your upper limit, and then a is your lower limit. Okay, so to get the area of this, so you just need to get the antiderivative of x, okay, from b to a, and then that's it. And take note that the x values here are all positive, okay? Everything here are positive. So obviously, if the shaded area is on the left side of the y-axis, that's a negative function. So that's it. That's for the y-axis. So let's have one example. Okay. So this is example number 7. So the diagram shows the shaded regions A and B. So we have 2 here. So we basically need to find the areas of regions A and B given x is equal to y, times 2 minus y. So what do we do? So first, let's find for the area of the shaded region A. Okay, so this is now our equation. So this is in terms of y, not in x. Okay, so getting the antiderivative of that, so from here, it became this. So I basically simplified this right away. So I now have 2y minus y squared. Okay, so I think everyone knows that. Okay, so let's find the antiderivative of this from 2 to 0. Again, this is 2, and then this is 0. So the answer here is y squared minus y cubed over 3. So the antiderivative of 2y is y squared, okay, came from here. And then negative y squared is negative y cubed over 3. Okay, again, it's plus 1, so it's 3n over 3. So let's evaluate this now. So this is my upper limit. So this is 2 times 2 minus your lower limit, okay, which I bothered to write here. So basically, this is a big 0, okay. So answering this, the area of the shaded region A is 4 over 3 square units, okay. So that's your answer for the shaded region A. Again, do take note that your expression now or your function now is in terms of y. Unlike this, look, this is in terms of x. See, x here, x here. Right now it's y. Now let's have the area of the shaded region B. So here, so obviously, this one is also attached to the y-axis, but then it's on the left side of the y-axis. So that means that this is multiplied by negative 1. So from here, if you multiply this by negative 1, so you'll now have negative 2y plus y squared. So that's now your new expression. Okay, so please do take note of that. And now we are bounded by 0 as our upper limit here, and then negative 1 as our lower limit. So let's get the antiderivative of this. So negative 2y will give you negative y squared. Okay, this is the process right here. So negative 2, so y squared over 2, so cancel this. That's why you have negative y squared. And then evaluating this or getting the antiderivative of this, you'll get y cubed over 3. So let's evaluate this now. So this is my upper limit, so it's 0, because 0 is 0 here. Then minus your lower limit, which is negative 1, and then negative 1 here. So evaluating this, the area of the shaded region B is 4/3 square units. Okay, so that's your answer. Okay, so that's number 7. Okay. Okay, so 4/3 and 4/3. All right, so let's have one more. This is my last example for uh, 21.1. Okay, so again, this is a simpler one. Okay, so for number 8, so this is the shaded region. So we just need to calculate the value of this or the area of this. Now, but there's a slight problem. Your function now is in terms of x. Okay, this is y is equal to 4x squared. So we need to change this and make it in terms of y. So basically, we need to remove everything from x and put it in the or to the other side. Okay. So let's have this here. This is the process. So we're given y is equal to 4x squared. So what I did here is to remove 4 first. So divide both sides by 4. Okay, so 4 is removed. So that's why you have y over 4 here equals x squared here. Now, again, how do you get rid of this square? Basically, you get the root of both sides. So it's now just x. And getting the root of this, so you have y is raised to 1/2 over 2. Okay, so that's 2. So this is now your new function or new expression for number 8. So this now is in terms of y. Okay, or in other terms, this is the subject now is x, not y. Okay. Okay, so this is now your function. So getting the area of this, so we just need to get the antiderivative of this. Okay. So getting the antiderivative of y raised to 1/2 over 2 from 4 to 1. Okay, I think that's very obvious here. From 4 to 1. Okay, so this is the process. So basically, this is over 2, right? So this is basically 1/2. So what I did here is to set aside 1/2, and then 1/2 plus 1 is 3 over 2, and then obviously this is over 3 over 2. So let me simplify this. So this is now 1/2, and then how do you divide fractions? So basically you need to get the reciprocal of this. So that's why it became 2 over 3, and then you proceed to multiplication. So doing so, we can cancel out 2 and 2 right here. So we're only given 1/3. That's why we have 1/3 here, and then just bring down y raised to 3 over 2. So this is now the antiderivative of this one. Okay, so this is the process. Okay, so let's evaluate this now. So evaluating this, so upper limit times 4 minus your lower limit. Okay, this is 1. And then evaluating this, your answer now is 7 over 3 square units. So that's the area of the shaded region. This shaded region bounded by 4 and 1 being your upper and lower limit is equal to y squared minus 6y plus 11. So you need to evaluate this first, right? So it becomes y squared minus 6y plus 9 and then plus 2. So that's why you have plus 11 here. So getting the antiderivative of this, so we got here y cubed over 3, negative 6y, it becomes negative 6, and then y squared over 2 plus 11y. So simplifying this, so bring down, and then this one, so 6 and 2 becomes negative 3, and then y squared plus 11y. So let's evaluate this. Okay, so this is my upper limit. So 4 here, and then 4, and then another 4 here, and then minus your lower limit, which is basically 1, 1, and 1 here. So evaluating this in your calculators, you'll get 52 over 3 minus 25 over 3. And then subtracting this, our answer is 9 square units. So that's for number 10, A. Now for B, let me discuss B since it's here. So y is equal to x cubed, right? So this is not in terms of y. It should be in terms of y. So I'm going to express this in terms of y. So therefore, this is my new equation, this one. Let me highlight this. Okay. So this is what I'm going to use to get the area of the shaded region from 8 to 1. Okay. So getting the antiderivative of y raised to 1/3. So it becomes 4/3 because plus 1, and then over 4/3. And then simplifying this further, so again, getting the reciprocal of this, so it becomes 3/4 times y raised to 4 over thirds, and let's evaluate this. Okay. So evaluating this, so this is my upper limit, so 8, raised to 4 third times 3 fourth minus your lower limit, 1. Okay, raised to 4 over thirds times 3 fourths. So this thing becomes 12, and then this becomes negative 3 fourths. So your answer here is 45 over 4, or 11 and 1/4 square units. So that's for letter B. Now, for letter C, okay. Now, we're given here P and O. Basically, this is 0, right? But how do we find for point P, or the y coordinate of point P? So it lies here. Again, if your points are on the y-axis, that means x is equal to 0, right? So therefore, okay, to get the coordinates of point P, okay, so this one, your equation 2y times 2 minus y is equal now to 0. So equating each of this by 0, so y is equal to 0, so that's this, right? And then the other one is 2, because 2 minus y equals 0 is 2. So p here is equal to 2, okay? That's how you get your uh, coordinates, okay? Again, you have 0 and 2 here. Now, for letter C, so if we got 2 and 0, so we now have our upper and lower limit. So let's evaluate this. Now this now is in terms of y already, so I don't have to do some math gymnastics here. So basically, just simplify this. You'll get 4y minus 2y squared from 2 to 0. So evaluating this, okay, or getting the antiderivative derivative of this, so 4y. So we'll set aside 4, so y squared over 2 right here. And then minus 2y squared, it becomes 2 here. Then y squared becomes y cubed over 3. And then simplifying this, so this is over 2. So this is 2y squared minus 2 thirds y cubed. Let's evaluate this. So this is my upper limit. So times 2 times 2. So from here, and then minus 0. Okay, so this one is basically 0 for the lower limit. So evaluating this, your answer should be 8 over 3 square units. So that's for letter C. Okay, that's for letter C. Again, this is 2 and 0 because of this process here. And then lastly, 10D. Now 10D, as you can see guys, the shaded region goes beyond the y-axis to the left side of it. That means that these things here are all negative, okay? Or we should multiply our expression or function by negative 1. So from here, this is in terms of y, but then since the shaded region is on the left side of the y-axis, that means this is multiplied by negative 1, so therefore it's now negative 1y or negative y squared plus 2y. So let's get the antiderivative of this from 2 to 0. Okay. Okay, so this one is negative y squared, so it becomes negative y cubed over 3 plus 2y, it becomes 2y squared over 2. So simplifying this, cancel this, so bring down this, and so it's basically just y squared again. Okay, so let's evaluate this from 2 to 0. So this is my upper limit. Okay, so I have here 2 plus 2 squared minus 0 again. So again, this is basically 0. So evaluating this, my answer is 4 over 3 square units. So that's the area of the shaded region for number 10, letter D. Okay, do you have any questions, class, for the questions on on number 10? No question, class? None? Okay. So I'm going to dismiss, not dismiss it. We're going to end now, okay? Alright, but for later's class, I mean our class later, okay, I want you guys to answer number 9. Okay, you can start doing number 9 right now. Okay, so you still have the 10 minutes. You can start doing number 9, and then I'll start with number 9 later, and then we jump to chapter 21.2, bounded by two curves. Alright, so that's it for us today. I'm going to, you know, uh, to give you 10 minutes. If you want to answer number 9, so okay. If you don't want, it's also fine. Okay, but I suggest you try to answer number 9 because it's between and okay, it's between an okay, it's between a curve and a straight line. Okay, so you're bounded by this. You need to find this area. Okay, so for this one, you need to at least subdivide your shape right there. Okay, all right. So for that, let me give you one example. Okay. So sorry for this. Sorry. So let me give you one example. Okay. Go to page 458. Okay. Let me give you one example. Okay. So this is number 2, letter A. Okay. So this one is okay, another example of finding the area of a shaded region, but then this time, okay, it's bounded by a curve and a straight line. So at least you guys can see, right? Okay. So for number 2, letter A, how do we answer this? So basically, you need to subdivide this shaded region. And what I did here is that I have region A and region B. Now, region A is below the curve right here, and it's bounded by, what's this? So this is 1, right? Because here is 1, okay? And then later for region B, you know, this shape, right? Okay. So how do we get the area of the shaded region for number 2A? So for region A, so this is your equation. So x squared plus 1. And then the limits are from 1 to 0. Okay, so this is 1 and 0. So getting the antiderivative of this, so it becomes x cubed over 3 plus x, right? So let's evaluate this. So evaluating this, so we have 1 cubed over 3 plus 1. So this is basically 4/3 square units. Okay, so this here is 4/3 square units. How about uh, region B? Now, there are two ways in answering region B. Okay, now if you want the longer way, basically you need to find the gradient of this line and then find the equation. So there's a lot of steps, right? But then, as you can see, guys, this is a triangle, right? So that's what I used to get the area of this shape of this region. So this is 1/2 times 3 times 2. Why times 3 times 2? So this is 1, right? Oops. Okay, sorry. So this is 1. So that means from here to here, that's 3 units, and that's your base, right? And then what's your height? So your height is 2. So this one is your height, 2 units, because of this y coordinate, right? So this is your base, this is your height, and then times 1/2, that means that's 3 square units. So therefore, the area of the shaded region is the total of this 2 here, so that gives you 13 over 3 square units. The diagram shows part of the curve y is equal to x squared. And of the line x plus y is equal to 6. And then these two are intersecting at point A. Okay. Calculate the area of the shaded region. Okay. So look here, this is your shaded region. And now basically what I did here is to divide them into two sections. Okay, two sections. Section A or region A and then region B. Now, I will solve region A and then region B. So the equation for region A is very simple. So as you will see, guys, this one is a triangle, right? So the base and height of my triangle is basically 2. So this is 2 and then 2, right? So therefore, getting the area of region A, that's equal to 2 square units. And then now, how about region B? Now for region B, I need to use the curve, okay? This one, this part right here, okay? So to get that, firstly, okay, I need to change my expression because it's in terms of x here. So basically, I need to change this first to y is equal to x squared, and it should be in terms of y. So basically, remove square. So squares cancel out. So x is equal to y or root of y or simply y raised to 1/2. Okay, so that's why I got this y raised to 1/2 here. That's the process I did. Okay, now going here, in solving for region B, so I'm bounded by uh, my upper limit is 4 and 0 because look, your shaded area or region here is on the y-axis. That's why this is your upper and then basically this is your lower limit. Okay, so let's find out the antiderivative of y raised to 1/2 from 4 to 0. So getting the antiderivative of this, so I'll be getting y raised to 3/2 over 3 over 2, and simplifying this, I should get 2/3. So just reverse this, becomes 2/3, and then just write this again. Now let's evaluate this. Now evaluating that, so basically for my upper limit, it's 2/3 times 4 raised to 3 over 2 minus 0. So because if you put 0 here, everything here is basically 0 as well. So therefore, my area or the area of region B is 5 and 1/3. Okay. So the total now or the area of the shaded region is 7 and 1/3. So just add the 2 and then that's it. Okay. So that's number 9. So that's our next example for 21.1. Now let's jump to 21.2. Now what if our area now is bounded by two curves like this, right here? Okay, what if you have a curve here and another curve here? So you need to basically find for this shaded region. Okay, so if that's the case, remember this class. Uh, you just need to subtract the functions for each curve or line. Okay, so let's say the function of f of x minus the function of g of x. Okay, so that's how you get your area, just that. And take note that both of the upper limit are the same for both functions. Okay, and take note of that. Okay, so let's have one example. All right. So our first example, it's in your book on page 461. Basically, it's not a curve and a curve. It's a curve and a line. Okay. So they have given you a curve and a line. Okay. But basically, it works the same. Okay. So the diagram shows part of the curve. Wait. Let me record this. Oh, I'm recording. All right. So again, the diagram shows part of the curve. Y is equal to x squared minus 3x plus 6. And part of the line, which is y is equal to x plus 3. Okay, so we need to find the coordinates of point A and point B. Okay, and then the area of the shaded region, which is R. Okay, so basically we need to look for uh, points A and B. So to answer letter A, we need to look at their intersection points. Okay, so at their intersection points, all right, these two here, or these two functions here, will always be equal. Again, these two functions are always equal within these two intersection points because that's why they meet here. Okay, they're the same here. Okay, so to get point A and point B, so basically we need to equate just the two equations. So x squared minus 3x plus 6 is equal to x plus 3. Okay, so just that. And then we need to solve for x. Okay, so basically since we have x squared here, so this is a quadratic equation. So what do we do when we have quadratic equations? We make this in standard form. What do I mean by that? Put everything on one side and then everything is equal to 0. So the other side is empty. It's equal to 0. So what I did here is to transpose x. That's why it became minus x. So that's why we have negative 4x here. Then transpose 3. That's why it's minus 3. So 6 minus 3 is 3 here. So this is what I got now. Okay. And then how do I solve for the values of x? So basically, the keyword here is you need to factorize, right? So how do you factorize this? So since these are not perfect squares, so factors of 3, sum of negative 4. So what two numbers, when you multiply them, it equals it, or it's equal to positive 3, but then if you add them, it's equal to negative 4. So basically my answer here is negative 3 and negative 1. Okay, because when you multiply negative 3 and negative 1, you get 3. When you add them, you get negative 4. Okay, so this is your factors. Now, what's next? So basically, to solve for the values of x, you need to equate each term by 0. So that's why I have here x minus 3 equals 0, and then x minus 1 equals 0. So my first x here, or x sub 1, is equal to 3, and then my second x, or x sub 2, is equal to 1. And then, of course, if you have two x's, you need also two y's, or two value for y, to get the coordinates of both points. Now, if x is equal to 3, by the way, to solve for y, it's up to you which one you want to use. You want to use the curve or you want to use the line? It's up to you, but it will give you the same value of y sub 1 and y sub 2. So obviously for me, I just use the simpler equation, which is x plus 3. Okay, so my y sub 1 is 6, so this is my first pair of points. And then for my second point, second y, so y sub 2 is equal to 4. So this is my second point. So therefore, point A is at 1, 4. Again, this is point A, this is 1, and this is 4. And then point B is at 3 and 6. Okay, so that's your answer for A and B. Okay, so let's continue with letter B. So letter B, what is the area of region R? Okay, so let's move here. Okay, so we need to find this now. So basically, class, here, we just need to subtract the functions of the curve and the line. But please take note, always start with the one on the upper side of the region. Okay, so this will be your upper curve or upper line, and then minus the lower curve. Okay. All right, so let's do that. So we have x plus 3 minus x squared minus 3x plus 6. So just that, okay? So before you answer this, you need to simplify this as well. Okay, so by doing that, I will have negative x squared. It came from this, okay? It doesn't have a pair, so just bring that down. And then this is 4x. It came from this and this one. So basically, this is now plus 3x because you have negative here, okay? And then 3 minus 6 because this is negative and plus, so this is negative 3. Okay, so this is your simplified function. Okay, so we need to get the antiderivative of this. So by getting that, this here became negative x cubed over 3 plus this one. This is 4, and then this is now x squared over 2 minus 3x. So simplifying this further, just bring down this, then just cancel 4 and 2, you got 2x squared, and then bring down 3x. So let's evaluate this, and take note, your upper and lower limit is 3 and 1. Okay, so we get that from letter A. So this is 3 and 1. Okay, now evaluating this, so this is my upper limit. Okay, so I know it's a bit long. Okay, but you can just plug this in your calculator and be very careful with the negative sign. Okay, so this one minus this one, okay, it will give you 4 over 3 square units. So that's your answer for letter B. Do you have any question, class, for example number 9? No question? All right, so let's have our basically last example for today. Okay, so number 10, the diagram shows part of the curve. So y is equal to sine x and y is equal to cosine of x. So basically you have trig values. Okay, okay, and then basically the question is calculate the area enclosed by the curves and the y-axis. So we need to find this. Okay, so to get that, okay, so upper minus lower. Okay, so cosine of x minus sine of x. Just that. And then take note that your upper limit is pi over 4 until 0. Okay, so getting the antiderivative of cosine, so you have sine. Getting the antiderivative of negative sine, you'll have positive cosine. So let's evaluate this now. So evaluating this, so we'll have sine of pi over 4 plus cosine of pi over 4 minus sine of 0 plus cosine of 0. So when you evaluate this, you'll get square root of 2. And then when you evaluate this is simply minus, this is minus 1. So therefore, your answer is square root of 2 minus 1 square units. So that's your answer for